Can everybody see my screen? Okay, so do you have, what about other classes? I mean, you guys just was talking about it. Do they have a class today or not? Okay, great. So for this class, you guys know that it's not remote. We are going to have in-person classes starting from next week. But if you cannot make it in person, just let me know. That will be fine and understandable during this pandemic. And the labs will be in person as well. So the first lab will be next Tuesday. It's going to be a very simple one. Um, so I have probably 3 to 4 slides to give you an introduction to this class really quick. So look at you can find out the information from Web Opus or from Canvas, the time, location, and for the labs. So make sure you attend the labs in your section. Okay. Office hours will be virtual, Monday, Wednesday, Friday from 8 a.m. to 10 a.m. That's the official office hour. You guys know that whenever you contact me, as long as I have time, I'm going to reply to your email and help you out. So it really doesn't matter whenever you are going to, you really need my help. Just show me an email if I'm available. I will help out. Okay. But during office hours, I will open this Microsoft meeting, Microsoft Teams meeting, and you can come over to discuss with your classmates and or simply just ask questions. Okay. I know probably you guys have a class during this time frame. Um, it's hard to accommodate everybody, so whenever you have a question, just contact me. Okay, doesn't have to be within that time frame. And you can find out the syllabus on my website. Just go to electronics.com. As usual, I have the link to the class on the first page. And also in teaching, you can find more links to other classes as well. And also for the labs. So all the 10 labs have been uploaded to the website. So they are all available now. None of them are being during development. So all of them are done. I spent a lot of time during this winter break to get these labs done. And textbook, the required one, or I'm going to use, so 70% of this class, the contents in this class will be from this Dr. Baker's CMOS circuit design, layout, and simulation, this textbook. And 20% will be CMOS VLSI design. That's optional. You don't have to buy it. But if you like, I highly recommend it because this is a really famous VLSI textbook being used for everyone in the US at least. I think probably in Canada, in Europe as well. So the person who wrote this book, Dr. David Harris, is a professor in a small college in California. It's even not a PhD granting college. It's a really small private college, but being arguably being considered as the #1 undergraduate college in the US. And his colleague, whose name is Sarah Harris, and she used to work in the same college as well. But in 2014, I guess, she found a job in UNLV, which is where I studied for my PhD. She went there. And so these two professors, these two textbooks are the most famous VLSI design textbooks in the world. And both of these two professors are kind of directly or indirectly related to UNLV, which is not a top 10 university in the US, which is pretty interesting. And 10% will be from this textbook, and this has been used for my Engineering 337 class, the analog electronics class. So because I think 50% of the students in the class are not from analog. So I do think I need to do a review, probably a couple lectures review um, for these students on semiconductor physics, like p-n junctions, and something we didn't cover in analog. For example, BJTs, bipolar junction transistors, which is the older version of transistor, not like CMOS is being used right now, and also the semiconductor industry, which is still a really important industry in the world right now. So started from the 1970s, where the first integrated circuit was invented by that time, and now everything is being driven by ICs. So it's good to learn these things. So we may have weekly quizzes, and the quizzes will be given in the class. So if you cannot make it in person in the class, you have to let me know before you cannot make it, before you will be absent from class. And I will schedule a time to send you an email, or we can schedule an in-person quiz somewhere in the Cedar Family Hall building or somewhere. Okay. And labs will be in person as well. The same as the lectures. If you couldn't make it, just let me know. And that's totally understandable. And all the labs will be on the website. It's using, I was debating with myself during the break. So I was thinking, like, should we use Cadence or Electric VLSI? So Cadence is being installed in one, it's like a personal server in my lab. So the problem is here. So the problem for Cadence is it's not, you cannot log in to that server out of campus. When I was in some other institutions, they allow them to do that, but the IT department over here are really reluctant to let our students to do this for safety issues. So if we use Cadence, I mean, just in case the campus is totally closed again in this semester, we will not be able to do any labs anymore. So that's why I'm thinking it's better to be consistent. And I still have Cadence running, and all the tutorials are already developed and already posted to the website. If you really want to learn something about Cadence, you can directly go there and check out all the tutorials. You are really welcome to do so. But doing electric VLSI is very similar. So the design concepts and the circuit design skills will be the same pretty much, just a different developing environment. So we will still use electric VLSI and LT Spice for all these designs, not Cadence. So which means you can download, no matter it's a MacBook or it's a PC, doesn't matter. You can download electric VLSI and LT Spice to your computer, and you can complete all the 10 labs just at home. If you, for example, you are in quarantine for like 4 weeks or 2 weeks, 3 weeks, you can still get it done. I mean, I think this is a better way to do it this semester. And I hope this will be the very last semester we have during this pandemic. And after the vaccines and rolls out, hopefully in the fall semester, everything will be normal. The lectures will not be provided live because some of the students may have internet connection issues, a lot of glitches, so I'm really reluctant to do so. So I will give lectures in the class in person, and I'm going to record it as what I did in the past. So you can check out the videos after the class. Okay. If you need some extra help, just let me know. I will be willing to help. For lab reports, so you have to upload your lab reports to the website. And if you already have a electronics not electronics, YI electronics account, you can keep using that one. It is still available. You can still use that one and just create an actual link. So you used to have, for example, robotics tool and my controllers, all these kind of links. So now it's just to create another link saying this is Engineering338 and just post all the lab reports to there. Okay. If you do not have an account yet, I'm going to send you an account over this weekend. So I'm still working on that. And homework assignments should be submitted in the form of hard copies before the class. Okay, if you are attending the class in person. If you cannot come to school, please take pictures of the hard copies and send them to me by email. Okay. And some COVID policies. You must have a recent negative result to attend classes in person. I think everybody has seen this in the email. And do the daily screening every day and show me the green pass every day at the beginning of the class. And also scan the QR code every time you enter the classroom. I think there will be a QR code on the door of the classroom. So scan it every time. Okay. That's everything I'm going to show you on the slides. And let me show something really quick for the class. Okay, if you click here, you can see that's a class, that's a web page of the course. The syllabus will be in a PDF form. You can download it if you like. And there are some videos to check out. When we are along semester, I'm going to let you watch some of the videos. And the basic information for the class, you can still find it here. And that's a link for the virtual office hour. Okay, just click it to attend it if you have questions during this time frame. And here's the schedule for the class. I have to schedule all the, plan out all the classes according to the labs. I cannot, for example, more logically, maybe after the introduction, I should start semiconductor basics right away. But because we are going to do a DAC lab next Tuesday, so I'm going to cover some DAC ADC basics starting from Monday. We'll do it again on Wednesday, so you understand what's going on, right? And then semiconductor basics, cover bipolar junction transistors, and MOSFETs, and the semiconductor industry, and yield. What is yield, right? So all these concepts in here, and then we are going to dive into the C5 technology, which is the 500 nanometer technology, pretty simple, 3 metal layers. For all the details of all the layers and digital design, some of the AOI logics design, clock circuits, the flip-flops, and special adders, and how to design a layout using stick diagrams. They are just some design techniques you can use to plan for relatively larger scale integrated circuits. And then memory circuit design, probably 2 weeks on that. So I probably have heard about RAMs, ROMs, flash, all these kind of different types of memories being used. And what are the companies that are fabricating memories? The main players in the industry, right? So all these kind of things you need to know. And like if I ask, what is TSMC, right? What is TSMC? Anybody knows TSMC? Nobody knows TSMC. So I probably will put some of these names and concepts into quizzes in the semester. So whenever during an interview with a company, when you are looking for a job, you'll know these kind of questions. So what are these? What are the roles for these companies in the industry, right? Like TSMC and Micron, these guys are fabricating. They have foundries to fabricate chips. But for NVIDIA, Apple, these companies just do fabless design, digital designs, but not fabricating anything. But some companies like Intel, they have both, right? So Intel is really a pioneer in this industry, starting from the 1980s in the Silicon Valley. But now it's so their innovation got slowed down, and they are trying to outsource 3 nanometer fabrication with TSMC. So that's why whenever somebody is talking about semiconductor fabrication, right now it's pretty much being dominated by TSMC and Samsung, right? So TSM, you can if you are looking at 3 nanometer technologies, probably only TSMC and Samsung can do it, and it's not CMOS anymore. So like 2 years ago, FinFET is still super popular, but now FinFET is already considered as an old technology. Not old, but kind of next couple years, there are some other newer technologies probably will replace FinFET being used in your CPU. So we'll cover all these things for in the industry, semiconductor industry here, and also for the memory design, RAMs, ROMs, and whenever you upload your code to the microcontrollers, it's being uploaded to where, right? To RAMs or to ROMs or to flash, right? They are memories. You have been probably have been ordering DDR3, DDR4 RAMs for a computer, all these RAM cards to extend the RAM of the computer to make it run faster, like the 16 gigabytes RAM you can buy right now probably is only like $50 or less. I don't know. DDR3, DDR4 are still popular, but in the next couple of years, last year DDR5 was launched. So, DDR 5 years ago, DDR3 was still popular, but now DDR5 is emerging. You can see how fast this industry or the technology is evolving. And so if during the interview, if somebody asks you, like, whenever you are uploading your code to Arduino, are you uploading the code to where? To like RAM or ROM, right? Or flash. So you should be able to know that. They are totally different memory cells, and during the fabrication, they have different fabrication process. So totally different structures. And we'll cover memory cell design. And there are a couple of weeks, probably somewhere we spend more time. So I probably have to move things forward so we can use all of the semester, all of the weeks in the semester. And for the labs, click here. So 10 labs, maybe some minor modifications will be applied to some of the labs, but I will let you know. But now I think it's ready. For next week, Tuesday, okay, we are going to do a review for the circuit analysis series. I was planning on run some of the circuit examples today during this class, but I think it may be a waste of time for 50% of you guys who are already trained extensively, in my circuit one. But for some of you took circuit one a long time ago, and you probably have forgot it. So definitely visit this lab, these lectures before taking this lab on Tuesday. If you haven't been in circuit one, then you must do it before you can, complete this lab, right? That's kind of prerequisite, but it's not really too hard. So the two important things: one is superposition, one is the Stevenin's equivalent. Because you have to know this in order to understand what's going on in the DRC, R2R DAC. We're going to simulate the week after next week, right? If you don't know what's going on, you cannot understand the R2R ladder, okay? So this is a must. Okay, just do it and complete the lab. So the deadline for this lab is normally, did I put the deadline here? Yeah, deadline is February the 8th, Monday, 10 p.m. as usual. Okay. And I'm gonna put a link here, and you are going to upload for someone is new to my class. Okay, you are going to upload your lab reports to the server, and when somebody click it, will see your lab reports. So I'm gonna print that web page, which is your lab report, by this time, and grade it and send it back to you through email. So if you are new to this class or to my classes, the way I did it is something like this, right? So you can see student labs and everyone has a link. If you click it, you can see all these labs, okay? So I'm going to activate this link later on. And then if you do not have a electronics.com account yet, I'm going to send it to you over the weekend. And the way to edit the web page or the report, okay, is here. Here's a tutorial to tell you how to edit the web page and upload it to the server. And you can download FileZilla from here. And also I have some web page templates you can edit over here. All right, so the purpose of the series of the labs is to let you start from fundamental digital cells, digital blocks, and then start building gates, right? Combinational logic, sequential logic, and eventually design an 8-bit ALU. For example, starting from a MOSFET, that's a transistor layout on the chip, something like this. Yeah, some of you may have done that in analog, but this is only lab similar to analog. It's good to review it. So here is a NMOS transistor. NMOS, yes, NMOS is grounded. That's an NMOS transistor. Starting from NMOS transistor, right, and then build an inverter. And it's slightly different from the analog inverter because you can see I'm trying to use a parallel PMOS and parallel NMOS here to get a bigger, a larger, or you can say it's a wider inverter over here. And simulate it as an inverter. And then NAND gate, NOR gate, XOR gates. That's a NAND gate, NOR gate as a stick diagram. So when you are planning on laying out something in the software, probably it's better to draw a stick diagram by hand first. So it's just helping you to design in the software. So that's an XOR gate like this, and that's a full adder. That's a huge full adder, and we're going to improve it later. So this is something, no-brainer. Just use this schematic to lay it out. Okay, and then how to use buses, right? If you have 8 bits instead of 1 bit, how can you make the schematic easier? Something like this. Instead of just doing 8 inverters, you can use a bus. So the bus is like a bundle of wires just to make the schematic easier. And that's a ring oscillator. Something like this. And we're going to scale up because VLSI stands for very large scale integrated circuits. It's not actually super large for this class. I mean, for the circuits. but it's relatively large scale. It's just a unit. You can expand it as you want in the future. Right? So this is mux and a better version of Flighter. So that's a mux, and here is a better version, improved version of Flighter, just using AOI logic. We're going to learn it along the semester. So here's a better version of Flighter, I think. Is that a Flighter? Probably, yeah. So you can compare the traditional Flighter and the improved high-speed Flighter. So it takes a lot less space compared to the traditional one. And here's the mux. That's that's an 8-bit Flighter. So just combine them together to make an 8-bit Flighter, right? And then ALU. ALU is a brain in the CPU. So CPU is a brain for the computer, and ALU is a brain for the CPU. And this is a simplified version of the ALU, 8-bit ALU. We have addition, subtraction, and here's the ALU schematic. And eventually, that's the layout of ALU. It may take like a week or two for you to lay it out. So these are all the components in the ALU. You need a mux, you need a high-speed 8-bit high-speed Flighter, and 8-bit AND logic, 8-bit OR, 8-bit inverter, 8-bit mux, a couple of 8-bit muxes, right, to form the ALU, and eventually put it in the path frame, okay, to create a chip. So that's the scope for all the labs you guys will be working on during the semester. I think that's it. That's whatever I want to show you today. I just want to let you have a chance to ask questions if you have any. Were you able to hear me clearly just now? Okay. Okay, great. Great. Any questions or anything? No? Electric? Yeah, electric VLSI is, I have a tutorial on that. So go to my website and go to tutorials. The main web page, go to tutorials on the top and find out electric VLSI. So there are 5 tutorials. So the tutorial 1 includes all the instructions on how to install it and run it. There can be a lot of frustration at the very beginning when you run it, but after you know how to do it, it's very easy.